tungsten line is complex, but actually quite easy once you get into the weeds of it. You have a large chemical reactor, which you feed with your input of ore and soda ash. Your ore is going to produce these byproducts. Directly, you get carbon and oxygen from tungstate. You get calcite from scheelite. Scheelite has to be electrolyzed. A portion of the soda ash we produce by the end of it also gets electrolyzed here. Oxygen and carbon go back in to form carbon dioxide. We're going to get a small excess of it over time, so make sure you have a buffer. And using the salt you get from your sodium tungstate, your ore product, getting chemically bathed in hydrochloric acid, you split it in half here. You're going to get a lot of salt. A lot of salt. I have a filter here so that these tungstic acids don't bleed into each other. So we have 2 chemical baths here, each for each chemical bath, respectively. Your salt goes back into the reactor and forms ammonium chloride and sodium bicarbonate using a supplement of water and those prior ingredients. You're going to have a small amount of ammonia already included in this, but that's okay. Now, the sodium bicarbonate output is going to be electrolyzed in this electrolyzer. From it, you get soda ash in these liquids. Water goes up here. Carbon dioxide goes out back from it, right here, using this shared pipe. Additionally, you're going to get ammonia, the gas, which goes in here pretty easily. Your net on ammonia is 0, so you don't need a buffer. This repeats the process of forming ammonium chloride and sodium bicarbonate. As a happy bonus, you get your hydrochloric acid back from electrolyzing ammonium chloride, which gets split in half amongst these 2 chemical baths. I recommend to start with a buffer of 16 buckets per chemical bath. The soda ash you get from electrolyzing sodium bicarbonate gets split here. 1 out of 6 of your soda ash should go back into your large chemical reactor. The other 5 parts need to go into this electrolyzer that I mentioned earlier to form more carbon dioxide in order to fill in the gap that you're going to have of carbon dioxide. Because when processing, when electrolyzing the sodium bicarbonate, you only get half of the CO2 and water you need. So you need a extra push of carbon dioxide for it. So that's where this comes in. You also get an extra push from the extraction of ore, but just to be safe, do it like this. Pretty easy. Well, actually, no, not to be safe. It's mandatory because if you wanted all your carbon dioxide back, you'd use all your soda ash, but you need some soda ash to process the ore. So having this small cut of extra carbon dioxide is really good. After this extremely complicated process, I hope you can figure that out, we have this. This part is a lot simpler. We have an ammonia that we get back from our sodium parent tungstate. We have we've got this son of a gun, this pyrolysis oven. It has 2 input hatches that they each use for this distillery because I really wanted to also have this spot where the hydrogen gas gets put in, the one you recover, that you need also for burning the resulting tungstate oxide into pure tungsten dust. Yeah. Behind this is the pyrolysis oven thingamajig. So yeah, nothing major there. Or you can just have it out back and put the maintenance hatch there. Yeah, this is the much easier part because it's just like the loop of the pyrolysis oven. This is the complex part. I hope you can figure this out. Again, The chemical reactor loops your ore processing, your carbon dioxide, your sodium bicarbonate, and ammonium chloride, which get electrolyzed to form these. Make sure you split your soda ash 1/6 back into the reactor, 5/6 back into the electrolyzer. Use robot arms with specified amounts to do it. Make sure they're LV, because at a time you're not going to get more than 6 soda ash per tick. So you want them to split properly. And if you do more than this, it's going to result in this arm taking a lot more than this arm. It's a shame you can't do fractions with stuff like this. Make sure your filters are all set to extract, or if you're not like me, just place them in the machines and make them insert by default. Make sure you have a filter here for salt, so that these don't bleed their tungstic acid over to each other. Make sure that your filters are set correctly and that your monodirectionals are properly set. The pipes don't have to be neutronium, don't worry about it. And yeah, make sure that everything is just running as it should, okay? So like, again, take a look at this. This is the ammonium chloride and sodium bicarbonate thing. Make sure that you split your sodium tungstate in half, because you're when you overclock your thing so strongly, which, like, you have no reason not to overclock excessively your large chemical reactor. Put a 16 amp EV hatch on this thing. It truly doesn't matter because it's a perfect overclock. You don't spend more energy for faster speeds, you spend the same amount of energy for faster speeds. Yeah. Have a network here, an item pipe network, so that you can get your, I guess, your waste byproducts, your sodium, your lithium, your calcium. And then yeah, here finalize with tungsten. It is best used with, best used. Oh yeah, you're also gonna need a nitrogen supplement. Forgot about that part. Yeah, best enjoyed with how much of this am I cooking at a time? Hold on. Let me see this. Yeah. Yeah, I'm doing like yeah, no, this is the math here works out to like six tungsten at a time. This is like batch. So like you're gonna have a buffer of 20,000 ammonia, a buffer of 48 32, because I just kind of, this is it recovers itself in the time that you need more, so we're gonna be good. 24 soda ash initially, a little bit of ammonia. It's all recovered pretty smoothly. So yeah, like 15,000 in these, pretty good, because like the distilleries is the most painful part of this, because they are slow. Of course, once you get an evaporation tower, it becomes easier, but yeah, it's gonna be a lot more clunkier, because incorporating a multi-block into this is pretty annoying, but who cares? It doesn't matter that much.